Hello, thank you so much for having me today. My name is Yunseo, and I'm currently a senior at Phillips Exeter Academy. Today I'm here to talk about my theoretical economics STS project on two-sided matching in infinite markets. And so yeah, I'll dive right away. Matching is a branch of economics that has seen many real-life applications, such as matching students to schools in New York City and Boston, matching doctors to residencies in the National Residency Matching Program, and matching cadets to branches of military in the USA Military Academy. Matching theory essentially boils down to this question of how we can form pairings between two sets of agents. And because matching theory has many real-life applications, it's important for us to understand the behaviors of matching markets in order to derive the most efficient algorithms and the fairest policies. In particular, in my project, I studied the infinite matching model, where instead of having a finite number of agents be matched to another finite number of agents as the usual, we have an infinite number of agents be matched to an infinite number of agents. This particular object is important to us because it can help us study the behavior of large finite markets. As large finite markets keep increasing in size, they converge to infinite matching models. And to understand this convergence and better approximate the behavior of large finite markets, it's important for us to understand the behaviors of these infinite matching models. In order to study the behaviors of infinite matching models, I use the marriage model. The marriage model characterizes the problem of matching using sets of men and women and their preferences upon each other. And so in addition to ranking all the women, each man will have to rank another option, which would be to remain single, and vice versa for the women. And now before I move on to say anything else, I quickly want to make a note that this model is very outdated in today's standards. But because the baseline framework has been a stand-in problem for studying matching in finite models, I will carry out this notation throughout this presentation as well. But yeah, back to the model itself. Given a set of men and women and their preferences upon each other, it's natural to ask about how we can form the best marriages. But it turns out that we're not the first people to ask this question. Gale and Shapley in 1962 proposed this problem of how we can form stable marriages, as if they had seen any reality shows back in the 60s. But to Gale and Shapley, having a matching that is stable meant satisfying these two different criteria. The first would be so that every agent is content with their partner. The second is that no agent should have the incentive to form an affair. And so putting this more formally in the context of preferences, this would mean that every agent would want to be with their partner more than they want to remain single. And the second criteria can translate to being that no man and woman pair should prefer each other more than their respective partners, because if so, it gives them incentive to break their respective marriages and form an affair. Gale and Shapley show that in any finite set of men and women and their preferences upon each other, there always exists a stable matching. And since then, many scientists have studied stable matchings in finite models. And so in my project, extending upon their findings, I sought to investigate which of the finite matching market properties extend over to the infinite matching market or do not. So the first immediate thought that comes to mind is that it's going to be really nice if these proofs in the finite matching model extend naturally to the infinite matching model. But it turns out that this is not the case. For example, in the way that Gale and Shapley showed, in order to guarantee the existence of a stable matching, they rely on the termination of certain algorithm. Other times, these proofs rely on the fact that there has to be a minimal or maximal element, which becomes blurry once we move on to this infinite setting. And so in my project, using algebra, combinatorics, and logic, which hasn't been the most traditional way to study matching, I sought to find which of the properties in the finite matching model extend to the infinite matching market or do not. In this presentation, I omitted a lot of details because of the length, but I would always love to talk more about my project, and so please feel free to reach me, and thank you so much for listening to me today.